Hello, my name is Mrs Kershaw and I am one of the Science Directors for Outward Grange Academies Trust. Today's lesson we will look at testing for negative ions in ionic compounds. This forms part of the triple only specification in the C8 unit analysis. Our challenge today will be to identify non-metal ions using test tube reagents, and our aspire is to be able to construct balanced ionic equations. But before we start, let's see what you can remember about how to test for the different gases that we might find in reactions. 3 minutes, off you go. How did we get on then? So, to test for oxygen gas, you need to insert a glowing splint. The result of the test, if oxygen is present, is that the glowing splint will relight. The next one, the test for hydrogen gas, a personal favourite of mine, it is not the squeaky pop test, as many people write. The test is to insert a lighted splint. The result of that test, if hydrogen is present, is that a squeaky pop will be heard. Many students lose marks for this in exams by just writing the squeaky pop test. Carbon dioxide gas then. The test for this is to take the gas and bubble the gas through lime water. The lime water will then turn cloudy. And finally, the test for chlorine gas is to add a piece of damp litmus paper. The litmus paper will then be bleached white. It's important, particularly with today's lesson, that we understand that the test for chlorine gas is different to the test for chloride ions, which is what we're going to look at today. If you are unsure of these 4 tests, then pause the video now and make a note of them. The test that we're going to look at today is the test for negative ions in ionic compounds. It's important that we remember that ionic compounds exist as giant ionic lattices, which are formed by the electrostatic force of attraction between oppositely charged ions. This means that in an ionic compound there will be 2 ions, a positive ion and a negative ion. So when we are testing to find out what the compound is, we will need to do 2 sets of tests, one for positive ions and one for negative ions. Today's lesson we are going to focus on the negative ions, sometimes referred to as anions. There are 3 types of ions that you are expected to be able to remember the tests for. The first group are the group 7 ions, halide ions, chloride, bromide and iodide ions. The second type of anion is a sulfate ion. And finally, the third type of ion is a carbonate ion. In the following video, Mrs. Jennison is going to explain and demonstrate how to do the tests for the 3 types of ions.
Hi everyone, so in this video I'm going to do some tests for halide ions. Now for the halide ions we add the same reactants but we get a different colour precipitate form depending on which ion is in the compound. So I have solutions of chloride, bromide and iodide ions. The first thing I'm going to do is I'm going to add some nitric acid to each one. Then I'm going to add a small amount of silver nitrate solution and we will see a precipitate form. So I'll add that to chloride first. And we can see a white precipitate has formed of silver chloride. So now if I add it to bromide, we should see a different colour precipitate form. Now it is very pale, so I'm going to put it next to the chloride and you should see that it's slightly darker and we say that this is a cream precipitate. So now let's add some silver nitrate to our iodide ions and again we can see a precipitate has formed. It is slightly darker than the bromide precipitate and it's more yellow than it is cream. So that is the test that I can do to identify my different halide ions. So now that we've seen the test for halide ions, there is a different test for sulfate ions. So we're going to need some different reactants. So now, instead of my previous reactants, I'm going to use hydrochloric acid and then I'm going to add barium chloride and I should see a different precipitate form. So I'll add that hydrochloric acid first to my sulfate ions and give it a small mix. And then when I have my barium chloride solution, we should see a precipitate form. And if we look at the colour of that precipitate, it is quite clearly white. So that is the test for sulfate ions. We're going to test for carbonate ions. Now, in this test, we do it slightly differently to the other ones, and the reason for that is we end up testing for the gas evolved when carbonates react with acid as a way to identify them. So we add acid to our sample containing carbonate ions, and as we know from earlier topics, that will then produce carbon dioxide gas. So if we bubble that gas through lime water, it should turn cloudy. So I'll just add my acid. And as that's bubbling through, we should start to see the lime water sample turning cloudy. And that is the positive test for carbonate ions. And it looks like it has turned. So if I move the tube out, we should be able to see it more clearly. Sometimes you could be asked to identify both the metal and the non-metal ion in an unknown sample. So you would have to use a series of these tests to make sure that you identify both of those types of ions.
So let's just recap the tests that Mrs. Jennison explained on the video. First of all, looking at the test for halide ions. These are ions of elements in group 7. The first step then is to put a sample of the unknown solution in a test tube. We then add nitric acid to each of the test tubes. Now it's important that we remember it's nitric acid. We are testing for chloride, bromide and iodide ions. If we were to put, say, hydrochloric acid in there, then we would be adding chloride ions using the acid, so that would give us a false test. Nitric acid will not interfere with our test, but it will remove any other ions there that we don't want to test for. Finally, we then add silver nitrate solution to each test tube. This should then result in the formation of a precipitate if a halide ion is present. Chloride ions will form a white precipitate, bromide ions will form a cream precipitate, and iodide ions will form a yellow precipitate. This is sometimes difficult to distinguish between them. The iodide is obviously a yellow, but the other two, without putting them next to each other, can sometimes be difficult to see. Test for sulfate ions then. This time, the first step, again, we put samples of the unknown solution into the test tube. We then again add an acid, and this time we can use hydrochloric acid because we're not testing for chloride ions. The only acid we couldn't use is sulfuric acid because that contains sulfate ions. If you wanted to use nitric acid, as we did the previous test, that would also be okay. The final step then is to add barium chloride solution. If a sulfate ion is present, this will then form an insoluble barium sulfate precipitate. This is usually white. And finally, the test for carbonate ions. I'm showing you the equipment here because we need a little bit more than we've needed for the previous tests. So we are going to need an acid, and this time you could use any acid that you wanted, but in this example I'm going to use hydrochloric acid. We are going to need a delivery tube this time because we need to collect the gas. And finally we're going to need some lime water because we're going to have to bubble the gas that we collect through lime water. So just like with the other tests, we will add the unknown solution to some test tubes, followed by step 2, adding some acid. And again, in this one you could have used nitric acid, you could have used sulfuric acid. We've chosen to use hydrochloric acid. If a carbonate is present, then bubbles of carbon dioxide gas would be produced in the reaction. So we need to record if bubbles are produced when we add the acid. If they are, then you can take a fresh sample and collect the gas using a delivery tube and bubble that gas through lime water. If the gas is carbon dioxide, then the lime water will turn cloudy as a positive test. That finishes a recap of the tests then. So let's move on to our Aspire, which is constructing ionic equations. Now, a balanced ionic equation shows the ions in the chemical reaction. Sometimes there will be ions in the reaction that do not take part, and we call those spectator ions. And because they don't take part in the reaction, we do not include them in ionic equations. And for those of you who have already watched the video on cation testing, then you will have seen this before. A reminder then of state symbols, because these are important in ionic equations. So small s in brackets is solid, and L is liquid, G is gas, and AQ is aqueous solution, which means it's dissolved in water. Let's start with looking at a worked example of barium chloride and sodium sulfate. Barium chloride is the ionic reagent that we use to test for sulfate ions. Sodium sulfate obviously contains sulfate ions. Because these are both ionic compounds, when we dissolve them in water, they will split into their ions. You can see here that I have highlighted the chloride and the sodium ions on both sides in red. That is because on both sides of the equation they appear unchanged and have not taken place in the reaction. This means they are spectator ions and we can cancel them out. Once I've cancelled those out, what I am left with is the following equation. This is the ionic equation for the reaction, and you can see here why the state symbols are important. So you can see that the barium ions and the sulfate ions are in solution on the left hand side, but they have then formed an ionic solid compound on the right hand side, and that presents itself as a white precipitate. If we look here, this is the test for halide ions, and you can see that in each of these reactions the silver ions from the silver nitrate has reacted with the halide ions to form a solid silver halide. Okay, time for you to have a go at writing some ionic equations. I've given you 3 examples here, and I would like the balanced ionic equation for each of the reactions. 3 minutes, off you go. So grab a red pen, let's see how you got on. Did you remember that for each of the equations we need to discount the spectator ions, so we're only looking at the ions that take part in the reaction? And finally, the reaction between silver nitrate and copper sulfate would present no reaction because silver nitrate is a test for halide ions and copper sulfate contains no halide ions. For a reaction with copper sulfate, we would have needed to add barium chloride to test for the sulfate ions. If you need to pause the video and correct your work, do so now. Finally then, let's look at what this might look like in an exam. So here we have a question that talks about fireworks. If you've done the cation lesson, you will have seen the beginning of this question where we were testing for the positive ions. This part asks us to test for the negative ions. Part E is asking you to remember which colour. As we said previously, with these analysis questions, you do need to learn these colours. That's probably better done earlier rather than later. Part F then asks you to describe a test. So that means we're going to say what you see. So we're going to explain the test and then give the result of the test. 4 minutes, see how you get on. Right, so let's mark your work. A cream precipitate with silver nitrate would indicate that bromide ions are present. Please note in the mark scheme they do not accept bromine. It is bromide ions. It's the ion, not the element that we're looking for. The second one then, to test for sulfate ions, we would add barium chloride and we would add hydrochloric acid. And we should see that a white precipitate is produced. So let's just summarise all the ion tests. Now here you can see I've got a flow chart, and I would suggest that when you begin anion testing, you add nitric acid. If we see any bubbles produced, then we can collect that gas and bubble it through lime water and test for carbonate ions. If no bubbles are produced, because we've used nitric acid, we can go straight to adding silver nitrate and testing for halide ions. If we get the different coloured precipitates, then we know that halide ions are formed. If we do not get a precipitate with silver nitrate, then we need to get a fresh sample and do the test for sulfate ions. So in this case we can add barium chloride and hydrochloric acid and look for a white precipitate. On the following slides then is a summary of what we've covered in today's lesson. If you wish to record that in your book, then you can do so now by pausing the video.